Hello everyone. I've been working on some really exciting stuff. I'm going to do a short kind of breakdown as to what I've been working on and how I'm going to implement it and how it actually functions. So as you can see with the face tracking here, I'm using Faceware Live. It is a face tracking software that is mainly meant for use in animation and production environments, but they do have a live bit that allows some integration into real-time games. So the thing about it is essentially it's putting these points on my face, and as you can see, I have my glasses on, so it's going to be. But as soon as I take my glasses off, I'm going to get much better face tracking, and even when I move around like this, it'll track pretty well. You can calibrate it. Let's see here. So here you can actually get a neutral position, calibrate it, and then you're off. It's this right here shows. I turn this on and off. That's just broadcasting to port 802. So now, as long as I have the plugin in Unreal, it's going to be broadcasting the values that you can see here with the different predetermined. This is all right out of the box. I didn't have to go through and pinpoint each one of these, but it's broadcasting these in real time. So you can see it's having a little bit of trouble tracking my eye. Let's see there, it got back on track. But you can also see that I'm using a multiplier here, especially in with the models that I'm using, and I'm sure this isn't the case with all models. In this case, I am using a multiplier of 1.25 across the board. So yeah, that's where that's at. And so how that broadcasts into the game. So here, if we look. And this is the blueprint in Unreal, and I have the plugin, which gives me access to certain nodes in the blueprints, and also the C++ code. But I'm using blueprints, so I have this node here that I drag into the game, and that is essentially the receiver for all the data. And so then it goes through to these values that separate out, and then you can just start hooking them up to your blend shapes that are attached to your models. So right now I'm using a model that is out of what we character creator. Actually, no, this is a custom model that we did. This is a model we're using from some models that we made using FaceShift Studio a couple years back, which is a different piece of face tracking software, but amazingly enough, the blend shapes almost perfectly match up. You'll see there's well, those are the eyes that I just haven't hooked up because I don't have a bone for the eyeballs. But for the most of it, you just hook them up to whatever the blend shape is titled. So if you have a function over here that's mouth stretch right, and I have one over here called mouth right, and they just hook right up to each other. So as long as you know essentially what ones hook up with what, you can hook this up to any blend shapes, and you don't even have to use them all. You can leave some blank if you want to. And again, this right here is the head rotation and stuff like that. I have the head rotation hooked up through the animation blueprint, which is a kind of a separate thing that you can't hook up the head rotation in this type of blueprint. And if I was doing it for actual production game or something, I would probably do all of this in the animation blueprint and keep a little bit of it separated. But yeah. And so now when I play, okay, you get pretty accurate head rotations and blinks and it's not 100% accurate by any means, but for a gaming engine, this is fantastic. So that's kind of where we're at with the face tracking. And if you were in a video game and you were talking to a character that was giving this level of facial animation, you would totally think that that was some high-end animation running through your game. But it's all real time. So that's where we're at on the face tracking. I'm going to pause this so I can go to the next section. All right, So for the next part, I'm going to talk about how I'm getting the data from the EEG device, the BCI device, to the actual game engine. So for the longest time, I was trying to use a plugin that just I never could get to work, and there was a lot of problems with it. But when I finally discovered this idea of OSC data, things started to move a lot quicker. So you can see here I'm using the Muse. It's by Interaction, but it's called the Muse, and it's just really slick. Goes behind your ears, not really as obtrusive as the big emotive insight that I was using. So I like this one a lot better, and it was a lot easier to get the data into the game engine. So the way this works is actually through my phone. Now there is a way to do it through a piece of software on your computer. It's called Muse Direct, but I really do like this way through the phone. So I'm going to show you that today. What it does is essentially I have an app on my phone called Muse Monitor. And so this connects to the Bluetooth of my phone, and then on Muse Monitor, I can broadcast that. So if you can see here, this is actually the accelerometer data. So when I move my head, it tracks the accelerometer in the headset. So you can broadcast that data. So that's not the only kind of data it does. You can also look at the EEG values, which they go anywhere between 600 and 1,000, 1,100, somewhere like that. And that's actually tracking the electrical currents in your brain. And then it also has like individual alpha, beta, gamma, delta, theta waves. So this is just the brain activity, and it's measuring the different, bandwidth. So, and then so it's also streaming a bunch of other data that I can actually show you here how much data you actually get with it. So if I hit play and then make sure I'm broadcasting. So this is just raw data coming into the game engine. So over here, let me put my glasses back on so I can see. Over here we have this one. So viewport event graph. So this essentially is just bringing data from the OSC receivers, just like the Faceware receiver, and it's taking this OSC event and it's putting out all these different values, right? So I take all these values and I break them up, and then I put them in format to the text. So it gives me the IP that it's coming from, the address that it's coming from, and the value that it's spitting out, right? So that's how you get all of the different ones here. And so if I actually pause the value, you can see it says like EEG value, and then it goes away because it's on a timer. But if we pull up the log here, let's see, yeah, you can see a lot better here. So it gives you the event that it's coming from, the IP, the address, which is, here it's like Muse /EEG. Here it's Muse elements alpha absolute, right? So that's the alpha band value. And so I can take and so gamma band is one that's used in concentration. So people say, if you have a high gamma, you're highly concentrating. So that's something that's something of use right there. So if I can tie the gamma band to some value that I want to show my concentration, then all of a sudden I'm visualizing that data. So that's kind of the idea. And so it also has other things that, let's see, you don't necessarily think you'll need. It has, touching forehead. This is whether or not all the points on the monitor are touching your forehead and they're getting a electrical current or whatever. Then we have, mostly you get EEG in the waveforms, but there are a bunch of other things. Blink, there you go. So every time I blink, this is actually surprisingly accurate, which I've used in a couple of experiments here that I'll show you in a little bit. But you also have jaw clench, and as a matter of fact, I can show you here. So here are the ones that pretty much are the main ones that are constantly streaming. It's EEG, accelerometer, gamma, beta, delta, theta, and then down here's alpha. touching forehead, that's the connection. The horseshoe is a visualization of the connection, right? So that's just it's not really useful. And then the battery power, and then the jaw clench. The jaw clench and the blink are pretty useful. And then I do think that the bands are the waveforms are actually pretty useful. Now, I don't know enough about the EG yet to say whether it's useful or not, but I'm sure if I could, that's like kind of the whole of it. So I don't know what I could do to that yet, but this is kind of where we're at now. So that's why it prints out all of those values the way it does. So if we open up another project, I have here's something. Let's see, raw data wave bar. Okay, yes. Okay, so let me get rid of this. So this is something I just kind of come up with to visualize, and you can see right now it's static, but as soon as I start broadcasting, now I am in real time, like showing the values of each different band. So if I really say, oh, and I've got the blink value hooked up to the color, right? So every time I blink, and let me get the camera back on here. So you can see that when I blink, it's going to change the value in the color value, right? And so then another thing is the values that are going up and down. So I can, if I concentrate, hold on, let me. And get that beta and gamma up there. You can imagine the bottom being 0 and the top being 1 as far as a value, because that's normalized in the app. So, and again, you'll see that is all going through this phone. So, and I can pause it, and when I pause it, it completely freezes where it is, and when I start it back up, it'll start broadcasting again. But I love, and the only thing to connect the phone, and this is something that I just love about this project, is it just has to be on the network, right? So I'm broadcasting to the network, and I'm receiving in port, I think like 7001 or something like that. But that is, I could have this device on my head and be walking around with my phone and have this app open, and the game could be receiving it anywhere on campus because it's all part of the same network. I'm connected to the same Wi-Fi as the computer that it's running on, and that is something about this. And I haven't tested that any further than down the hall, but the concept is that as long as you're on the same network, it should work. But anyhow, and I say it's network because my computer does not have Wi-Fi. It's not like it has to be on the same Wi-Fi. What is it, router or whatever. It's on the network, which is amazing. Theoretically, I could have this running at main campus had someone here at Center for Brain Health fire up the Muse and the app and start broadcasting and receive it there. So that is something that I think has some potential use also. Again, this is all exploratory. So, all right, this is another experiment. This is essentially the data that we were just discussing affecting a particle system. So over here you'll see I have, I'm breaking out the beta value, which earlier I was talking about gamma and concentration. I'm actually getting better results, or at least more extreme results with the beta. But anyway, you can see that I'm taking it and I'm setting the particle size value in the particle system, and I'm multiplying the value of 0 to 1 by 16, so it's scaling a little bit more, and then I'm formatting the text to print it out so you can actually see the scale grow with the particle. And then up here I have a switch hooked up that lets me switch from the amount spawned. So I start at 0, and then I'll go to 10, 50, and then 100 spawned in a 500 by 500 area. And that's hooked up to this particle switch over here, and then the print string is just printing the value of the spawn rate. So If we go here, you can see that right now the value's there, but I haven't blinked yet, so I haven't turned it on. So when I blink, you'll see, it's interesting to see the different values. Like, so let me go back to there, that's 100, right? But 100 and the value of the scale is small. But if I start concentrating, I can take that up and maintain it. So, and then I blink, it turns it off again. Let me, so, and then if I just sit here and clear my mind, it's hard to get them super small. But anyway, you get the idea. And then again, and you see the values moving on the screen here, how it's, you know, you're seeing the track of the live data and everything. You'll see something fire and it's going through the system. It's actually a really great visual programming system. I love blueprints. But anyway, so that's another experiment. Oh, that's nice. Got really low there. Almost looks like wisp of dust. But there's a lot going on here, but you know, we could limit this and have an interesting switch between like dust particles and smoke, you know, maybe if they take the color values and everything out of it. But all right, so now I'll give you an example of both of the values working together. I mean, it's fairly straightforward. This one I've hooked up the face tracking the way it was normally. Again, I apologize for the lag that I'm getting from the video capture, but you can see that now if I smile, it doesn't necessarily smile on the screen, but if I, you know, open my eyes and stuff like that, and I can still make the purse my lips, things like that, and it does track. But as far as the corners of the mouths will not go up unless I concentrate. So if I sit here and concentrate, I can get a nice smile, and it'll even track a little bit of my talking while I'm doing it. But you know, you can see that I can hold this smile as long as I concentrate on it. Now I haven't completely got to a point where I can not have to like tense up a little bit while I concentrate on this, but you know, I can train myself to make it where I'll try to do that without tensing up. So. It's a little bit harder. If I tense up, it's a lot easier. I can really just set the neurons in my brain just firing like crazy. But if I just sit here and don't tense up at all, I can affect it. It's just a little bit slower. But yeah, so yeah, there you have both inputs working together to represent something that's not necessarily accurate to what is on my face. And you know, that hopefully, if I could sit here and figure out exactly, you know, what fires while I just smile, like, you know, while I smile, like, well, okay, I got lucky, I guess, but because I've done it before and it hasn't done it. But yeah, if I can figure out what fires while I smile, I could essentially like just think about what I do and then broadcast that smile without actually doing it. All right, so that's where I'm at right now. Kind of give you a breakdown of all the different things I've been working on. Now I'm going to start moving into how I want it to be presented. I have a few ideas on this. I think there's some possibilities with the idea of using the face tracking to drive two different modes. One where it's, you know, just like this, where it's tracking my face and all the little movements that I do, and then maybe another mode where it switches to a more BCI driven representation. Alternatively, it could be the idea of having some other data stream drive that. You know, my BCI device, and then and I think clamping the values from certain devices. So, you know, like I showed you having the beta drive the smile. So having, you know, obviously the blink and the jaw clench drive those, but then having, you know, I don't know, the gamma driving the eyebrows or something like that. And that way you can start to really see a visual representation, although it's not like a typical data visualization, but just a visual representation of this data coming at you. So anyway, thank y'all for taking the time to look at it. I welcome any and all feedback that you have, and I look forward to where the project goes. And again, thank y'all. Bye.